Fox asked how many people knew what a hanging chad was.
A hanging chat?
Yeah, who knows what a hanging chad is?
I remember hanging chad.
It's like, next year these will be his students.
Oh yeah.
It's 18 years ago. It's
Oh.
like, it's so bad. That's how you get elected in Florida. Hanging chad.
In Chicago, you just have to bribe the right officials.
With the right bribe.
Oh yeah. It's not that expensive.
Bribing doesn't work if it's not the right kind.
Yeah. Yeah. Police, you just buy them a few rounds of donuts. I wish I were kidding.
Chocolate filled.
Yes.
There are all kinds of variations with donuts.
Standard donuts will work with your average Chicago officer.
No, I think there's a difference between donuts and cake nuts.
And what was the other one? Cronuts or something like that?
Cronuts?
Yes.
Well, I'm healthier.
I've had one of those ones. It's actually pretty good.
What about corn nuts?
Those are okay.
Those are good. That's a different,
Yeah.
different category.
Different category. That's a different kind of nut.
Oh, it's not good dessert.
You can put. We could probably put those in a shotgun and use it as projectile. And I would imagine that would hurt too.
Yes.
But it's biodegradable. It's very green.
They actually discovered a worm recently that can eat plastic.
Yeah, I heard about that, and people are trying to capitalize that, by using those things to clean up the ocean and all kinds of stuff.
Yep.
Yep.
What, eats plastic?
Yeah.
Well,
It has no
plastic
problem
has got
processing
carbon
plastic.
stuff in it. It's got energy content. So anything that has energy content, something will eventually figure out how to metabolize it.
Yes.
Agreed.
The question is, what is the side effect of that, right?
That remains to be seen.
Well, I think climate change is no longer on the EPA website, so that's gone.
It's over. It's over.
It's over. Yeah. Actually, once we get past a certain point, the tipping point, there may be no coming back anyway. So let's just pretend that we don't know about it.
I think 2000 was the tipping point.
Yeah, I think it has happened already.
Oh yeah.
Gore tried to stop it. That was a hanging chad.
Yeah.
All right. So what we're gonna do today is to go through a few more topics, and particularly how to test your mobile apps. Okay, how do you? Okay, so let's just not read out of this one. Just think about it. Okay, just to turn in your project, I want it to be relatively bugless. So how do you test your app?
Put breakpoints in.
No. But how do you?
You hand it to beta testers.
You hand it to
Exactly.
beta alpha testers first, right? Alpha testers first.
You're the alpha tester. Please submit all bug reports. No, that's not going to work.
Just hire a team of scientists.
It'll be reflected as a part of your grade. Yes.
Just try out combinations of buttons. And
But what do you mean by all combinations? See, that is the problem, because the combination also applies to configuration. So once you change a configuration, you have to retest everything. Even the stuff that doesn't seem to connect to the configuration thing, you have to retest it because it might have some ripple effect that will change things that you do not imagine that this configuration is going to change. So now the question is,
Semicolon.
Hmm?
Like accidentally removing a semicolon.
well, if it breaks your code, it's easier because the compiler can catch that. Okay. On the other hand, if it's a logic error, then how do you test it? Okay. So I'm just going to challenge you guys, and this has nothing to do with mobile application and whatnot. I'm just going to challenge you guys to describe what is the correct behavior. Let's not even do sorting. Okay. I just want to test whether an array is already sorted or not. Okay, so I'm going to give you this kind of scenario. Okay, so here's a function. I'm going to use a C function here, but since you know Java, C is about the same. Okay, so this is is sorted is the name of the function. You give it an array of integers. You tell it how many integers there are in the array, and it will return some yada yada yada. So how do you test whether this subroutine is doing its job correctly or not? How do you describe the correct behavior of this subroutine? Not even knowing how it is implemented. It can be very stupid, can be very time consuming, can be very smart. But my question is, what qualifies as the correct answer?
Visual inspection. Visual inspection throws some values and sort it.
Right, but how do you describe it mathematically? In other words, when you're trying to do it autonomously,
The inductive stuff?
It's mathematical for one thing. Okay, so how do you describe that? This is supposed to return true if and only if the array is sorted. In other words, what do you mean by sorted? Right? Okay, so how do we express that? Okay,
I guess
so
we first have to define what is sorted.
okay, so you can say return value should not be 0 if and only if the array or A is sorted. But that doesn't really describe, what is the correct behavior, because if the array is not sorted, I can make it sorted. I can make every single element exactly the same. But it's sorted is not supposed to change the array, right? It's supposed to scan the array to see whether it is sorted or not.
Well, that's all this is. Okay.
So you have to describe that too. You have to describe and say, you're not supposed to change it. And how do you describe it mathematically? Those are the things that we talk about in cisp 440, which is discrete structure. It's kind of a math class.
So
Okay?
A of n is less than or equal to A of n plus 1.
Yep. So, in mathematics, you can say, for all, I in the set of 0 up to n minus 1, okay, the following has to be true, okay, n minus 2, because, we are checking ordering. So you have to say A bracket 0 or A bracket I has to be less than or equal to A bracket I plus 1. Okay, so that's how you describe it in mathematics, whether an array is sorted or not. But this does not say anything about, you're not supposed to change the content of the array. Okay, because if you don't specify that you're not supposed to change the content of the array, I can do something like this. Okay, I can say int I, and then I just say for I from 0 to I is less than n plus I, A bracket 0 gets 0. A bracket I gets 0. So now they're all less than or equal to each other. The array is now sorted. How do you say that you're not supposed to do that? Right? So just trying to express the correct answer of a subroutine that is just checking whether an array is sorted or not is already tricky. So now you throw this kind of problem at a mobile app where you have user interaction stuff, you have stuff that is being displayed. It suddenly gets a little bit more complicated, okay? Because this is completely static, okay? Give me an array, I'm supposed to tell you whether it is sorted or not. Now, for those of you who are smart asses and say, yeah, I know C++, we can just do that. No, not really. You just need to cast it, right? All you need to do is to cast and get rid of the int, the const. Then the compiler will go like, oh, I see you know what you're doing, I'll let you do it. You can get rid of the const. You can always cast the const away, okay, if you use a cast.
Just because you can doesn't mean you should.
Well, because the compiler trusts you, right? I mean, if you do not do this, if you don't do the cast, then it's still a const int, and then the compiler will tell you that the const int cannot be on the left-hand side of an assignment, okay? But if you cast it, then the compiler says, you seem to know what you're doing. I'm not going to complain anymore.
It puts too much faith in us.
Sorry?
Then when you call it, you pass the number 7 or something. It casts away the constant, the number 7, and changes the value.
You cannot
And then
pass
the
the 7 to
commander
it.
crashes or something.
You cannot pass the 7 because all arrays are passed by reference in
But
C.
I mean, if it was constant n, and you're saying we could have cast away constants.
But everything in C is passed by value. So you're still changing the parameter itself, except in this case you're changing the elements, because when you're passing an array, it is also always passed by reference, so that is always possible. Yep. Okay, so getting back to this slide here, okay, how do you test your apps? You have a lot of challenges, okay? The first one is, if you're testing something, you need a way to inject triggers, okay? You have to inject the input and say, this is the input, I need to know what the program is going to behave, I need to look at the output and then compare the output of the program to what it is supposed to be. That's testing. Is that making any sense? When you're testing, you need to present the input, you need to present the expected output, and then you're comparing the actual output to the expected output. If they match, okay? And you can define match in many ways, okay? You can define match as, you can use an algorithm and say, okay, these two are considered the same. They may not be identical, but you can define what is considered to be the same. But you still need all of those elements: an input, expected output, and then the observed output, okay? So, but when you're dealing with an app, or when you're dealing with a program that only makes use of the standard input file and the standard output file, stdin, or cin, cout, okay, it's pretty easy, because you can always present the same input and then observe the output. And usually, if the algorithm is simple enough, you can actually write what the output is supposed to be. Then you can use a text tool to do a compare and go like, are they the same? If they're the same, we're good. Use a second input, test input, check the output, are they the same? So you can keep a log of all of these things and do regression testing. Regression testing, okay, can someone tell me what is regression testing? I can find it and also talk about it, but it is important. Okay.
When
Go ahead.
Feature no longer works in the way it was intended in a new version.
Okay, that would trigger the necessity of doing regression testing. Yep.
Regression testing is testing everything that you already tested.
Yes. So you're basically stacking new tests upon old tests. You have to
Moving
keep
forward.
Yep.
But the old stuff always has to work, or should still always work.
Unless it is
Should,
deprecated, or unless you change the specification of the software, so that part is not a part of the expected behavior anymore. So regression testing is important, because a lot of times you find new bugs and you derive a new test to check after you fix the new bug, you derive a new test to test whether your program has the new bug fixed. Let's say it does, okay? It is not a known that a bug fix can introduce bugs itself. So while it gets the reported bug fixed, it can introduce problems that breaks existing code. So that's the necessity. That's why you need to do regression testing. Every time you change the code to fix a new problem, you have to retest all the known problems that had ever been reported in the past to make sure that you did not accidentally break one of the things, or one of the code, some part of the code that had already existed, that had been fixed already. So that's the idea of regression testing. Okay? But that means that the amount of tests that you have to do is going to increase over time, which also means you don't want to do it manually. That's the whole point, okay? You don't want to do these tests manually, because doing it manually has a few, problems, okay? The first one is it is expensive. If you're working for a company and you have to do all of these tests manually, somebody actually has to interact with your app, reading a script, okay? Interact with the app, record what is the output, check against what the app is supposed to do, and then move on to the next step, the next step, the next step, and the next step. It is expensive. And anything that is expensive tends not to be done. Okay, does that make sense?
Yeah.
Okay? So you don't want it to be expensive. And then the second thing is, people make mistakes. Okay, they look at it, they misinterpret what it is supposed to be. Am I supposed to click this button? After clicking that button, is it supposed to be a long click, a short click? They can misinterpret things.
And they skip a step and file a bug report.
Yeah.
That triggers
Yes.
a whole new set of problems.
Yep. So we want to automate tests, and there's no easy way to automate it, and I can point you to a link. Okay, so if you look up Android app testing, oops, it's okay, you will find the right thing. So the Android website actually has its own link, has its own way of doing testing. And just this morning I was looking up, Mockito, which is a suite that you can use to do just about any type of test with Java program, with Java code. So you can you can read this up a little bit, but it's not, as far as I can see, it is very tedious. Okay, it's great if you're testing whether your linked list is working or not. Okay, you can say add one more element, and it's supposed to have that one more element, and then you can generate an output and compare what the output is supposed to be as opposed to the actual output of the program. So it's a way to exercise whatever you're testing, but it is not by itself a file. So in other words, you cannot generate your test suite easily, because this seems to me that it is always, not always, but it seems to me that it is very manual, it's labor intensive. So if you look up the Y, it's easy, okay? The Y is, it's a mocking framework that tastes really good. It let you write beautiful tests with a clean and simple API. I hate adjectives like that. Okay, when it comes to technical documents.
It sounds really flowery.
Yes.
It sounds very presidential. Beautiful, very beautiful.
It's good.
It's huge.
It makes
You're
a
gonna
big
love
difference.
it.
Powerful.
Big difference. You're gonna love it.
Very powerful. Yeah.
And we're gonna get Mexico to pay for it.
So it says right here, massive Stack Overflow community voted this to be the best mocking framework for Java, and so on. So the key here is it is a mocking framework. Okay.
Oh, we're having fun mocking it already.
Yes. And we are also having Java, Top 10 Java library across all libraries, not only the testing tools, so it's popular. But when you look at how it is actually getting things done, it doesn't seem very attractive to me, because it is very code-based. In other words, your test suite itself is a Java program. So in addition to the app that you're writing, you have to
Test the test code.
exactly you have this is custom stuff. This is custom stuff. Okay, it does have integration with Android. Okay, if you look up the documentation, it actually has integration with the Android API. But you still have to kind of do all the manual stuff, okay, in Java code. You're not describing the test using XML or some other type of documentation format. You're actually saying, okay, in Java code, simulate this, simulate that.
Oh, I'm gonna like this one. I'm gonna like this one.
You can probably use a Java program to automatically generate the Java code itself.
Well, I don't mind coding. So to me, to have to switch to another language in order to express something always seems rather inconvenient. So if I try to describe my stuff in XML because I'm really going off and testing this, then I have to learn that dialect and learn that syntax and this I have to just learn the methods.
And then
even if
when
it's
you're working
tedious,
in Java, I'm already working in Java. Let me just continue thinking in that language instead of having to switch to a language I'm thinking in.
So I mean, I'm that's why I have a trouble with Android Studio layouts and stuff, because I just don't have the time to think that.
Well, to learn a new framework, because to use the framework effectively, you have to understand how things are organized within the framework.
And what I've learned, and for example, what I've learned right now in doing my Android, it transparently moves right over to the iOS. How I want to lay my buttons out, the width of the screen. They both have the same problems. It's all the same logic. Underneath it, how do I create the button? Okay, that's different. But the rest of it's transportable. And if I did it there with their constraints and trying to set it up, and I came over and tried to redo the app over here, I have to put in their mechanism for doing it. That doesn't even seem as portable.
Well, if you do it, but iOS is not Java based.
No,
No,
it's
no, it's-
Objective-C
or
and
Swift.
now Swift. Yeah,
Swift is a nice language.
What is it then?
Swift.
Swift.
Yeah,
Yeah.
You should start toying around with that one. You'll be blown away by the switch statement. It's
Hmm.
live.
No.
Swift.
Yeah, the switch statement is
By
live.
Apple.
And it's built for optimization, so they can completely unroll the whole thing. And so if you read some of the technical docs in the back end,
Mhm.
I think it's got a promising future if it wasn't just Apple.
Mm-hmm.
Yeah,
But
you can only use
who's
it
backing
on
it?
Apple.
Who's backing
Apple.
it?
Swift, actually it's an open source Swift thing, but Apple's promoting it.
Okay.
I think it only runs right now on Apple
I
products.
don't know, it's getting pretty open. You can, they have playgrounds now on your Apple device, I think,
I don't
so.
have any Apple devices. That's the
I
problem.
mean, you can basically open up your pad and start coding.
Okay, Swift is a general purpose multi-paradigm compiled
Oh, just added Linux.
programming language developed by Apple, and it's also available on Linux. Swift is designed to work with Apple's Cocoa and Cocoa Touch framework and the large body of extant Objective-C
Which is
code
for
written
Apple.
for
What that
Apple
means
products.
is they built APIs in Swift, which are, what do they call them? I don't know, there's no gateway, it's just the same call.
Okay.
So they basically turned it all into Objective-C underneath it, and ultimately it's just the name of an address, is how
Mhm.
they link their procedures through the selector.
Well, Apple has always, has always been experimenting with new programming languages. Like I remember years ago, even when during the days of the Macintosh, they were playing with Smalltalk, whereas nobody else would even touch Smalltalk.
Yeah.
Yeah.
The commercial people only want BASIC.
And then you have Google with their Go and Dart and
Google is by far a lot more conventional because they use PHP as a basis, they use JavaScript as a basis for most of their stuff.
Yeah.
So they won't make a leap like Apple does. Apple is much more willing to make leaps.
I think they want to tie the language to the chip.
Okay.
So
Which
as
was
they
the
get it closer and closer and closer, we're
Mhm.
going to come back out of the reduced instruction set, and
Mhm.
not really the complex instruction set, but more of a direct mapping expression to
Mhm.
the type of things we use or do.
Well, that was the original intention of Java. Java was intended to be implemented directly. The bytecode is supposed to be executable by hardware.
That was the first worm, right? Write once, read multiple, or run.
Write once, run on multiple platforms equally slowly.
Yeah.
Yes.
Yes.
I went to one of the first. I think it was the first, the Java 1 conference. In San Francisco, and people kept well, I should say, Sun Microsystem at the time kept touting how you can write code once and run it on any platform. And then somebody said, yep, equally slowly. Because it's slow. The virtual machine technology back then was really immature. So it was just a straight translation. Okay, here's a bytecode, translate to what the native code is supposed to do, and it would do it every single time. Even if it's a tight loop, it doesn't do any type of just-in-time optimization. So it ran really, really slowly. But yes, it did run on any platform. And then they also almost. Yeah.
And
then they also
still
had-
didn't get Swing to do it all correctly or something like that.
I think that was even before Swing. The
Swing
first
would have been an add-on, yeah.
Yeah, it was an add-on. And then even back then, back in those days, the garbage collector did not work 100%. So if you have circular, data structure, it won't deallocate it. Yep, you can remove all the external links into the donut, and it won't deallocate the donut because as far as the objects inside the donut is concerned, they all have non-zero references. So the garbage collector will go look at them and like, nope, we cannot get rid of these. Even there's no possible way for your code to actually access it. It doesn't do that analysis correctly. Now, obviously, those things have all been fixed. But I remember those days when I was writing the program in Java thinking, oh, this is kind of cool. Not cool anymore when it chews up memory like there's no tomorrow.
This one's really simple. It's
Swift to learn.
yeah, it's easy. It's really an easy language. I like the way its expression You know, if you come out of C# or any of those types.
Cool.
My only problem is it's Apple. I've never had a good
I like
experience with
motorcycles
Apple.
and cars. I'm not
Yeah.
really particular.
Oh yeah, no. I just
I
don't
even
like
drive trucks.
anything. I've tried a lot of Apple products. I just haven't found one I've ever actually liked.
Well, maybe it's originating from Apple, but is Apple still steering this language like Oracle is now steering, Java? I mean,
Yeah.
I think so, yeah.
Yeah.
Okay.
Oh,
Yeah, they're up to
their
like,
developers
they're like
are
at
the ones-
Swift 2 or Swift 3 or something now.
Okay.
And it's and they're trying to make it a parallel language.
Well, that's
They're
what it
trying to
says right
catch it
here.
up to
Parallel
the-
scripting
And
language.
that's really where the game is when you go multi-core, because if I have to do now, I prefer to do the multi-threading in the smart way where I communicate and you run an independent thing, but a lot of them do the just clone copies of each other.
Mm-hmm. Well, if the language itself, is capable of expressing parallelism, it really helps the compiler to schedule instructions. That has been, okay, this is kind of off subject a little bit, but nonetheless kind of important. The Intel processors, the i3, i5, i7 processor, or even the Core 2, they have many ALUs, okay, arithmetic logic units. They have multiple integer ALUs and multiple floating point ALUs. And at any time, you can carry on multiple calculations at the same time, addition, subtraction, multiplication, and stuff like that. But the problem is, when the instructions are sequential, this instruction is adding, that instruction is comparing, this instruction is adding again, and so on and so forth. And then these sequence of instructions have dependency. So this instruction may rely on the result of that calculation, which relies on the result of that calculation, and so on. So you can see that so there are instructions that are expressed sequentially, but potentially some of those can occur in parallel. Okay. So the early days compiler, ran into this problem, especially with the Itanium. The Itanium had a very awful instruction set, which made it very difficult for compiler people to truly utilize all of the ALUs as much as possible.
But AMD
So
fixed that.
AMD fixed that, yes. But even the processor, the hardware, the Intel processors, as well as the AMD processors, they actually do hardware-based runtime dynamic scheduling. So they would look at the incoming stream of instructions and then automatically try to schedule the execution of the instructions to maximize the use of the ALUs. So that's a problem, because if you do anything in hardware, it's going to use up silicon. It's going to use up energy. It will decrease the energy efficiency of the processor because you're relying on silicon to do it. If the compiler can do it, it's much better because the compiler is doing it only once, right? It's not using any silicon. It's not going to make the device run any harder than necessary. So having a programming language that can express parallelism is actually nice because now the programmer, can intelligently, and say, oh, these things can all happen at the same time. So you don't need to use the compiler to do all the optimization because optimization is difficult. Any type of optimization of this kind, like you try to do the scheduling based on the architecture, is typically, the optimization problem itself is typically NP complete, which means it is a very difficult problem to solve. Okay, it takes a lot of time. Now you might be able to speed it up by looking at it and go like, oh, but this is a specialization of the general, optimization problem, and you can optimize it a little bit, but it still takes a lot of time. Okay, the more registers you have, the more ALUs you have, it will impact the execution time or the optimization part of the compiler, not in a linear fashion. It's not like you have twice the ALUs and twice the number of registers. It will just increase the optimization subroutine to take twice the amount of time.
And run in half the time.
No, it's proportional to the factorial, which is really bad because n factorial grows faster than 2 to the power of n. No, I take it back. N to the power of third, fourth, any type of polynomial is going to be slower than n factorial. So n factorial is really bad. But getting back to this one, being able to express parallelism is really nice because it can potentially lead to more efficient hardware because you don't need all that fancy hardware-based instruction rescheduling in hardware. So therefore you can save silicon, and as a result your mobile device can potentially have a longer battery life, which is really a big plus. This is partially why we don't use i5 i7 processors on mobile devices. There's just no way you can do it. It just doesn't have the energy efficiency to do it. Okay, so very good. Okay, we just explore what is Swift. Is it difficult to learn compared to C, C++, and Java? Is it like completely different, or is it kind of like?
No, it's a C-based language. Yeah.
Oh, it's C-based. Okay,
Yeah.
gotcha.
It's you've something to do when you're in the break. You'll come back and say, hey, I kind of like this toy.
Yeah, personally, this is who I
Oh.
am. I'm a Perl monk.
I left Perl at Perl 5.
Yeah, Perl is. I think there are multiple reasons. Okay, do they still have that?
Perl is an awesome tool.
Perl is very
Emphasis on
interesting.
was.
Hmm?
Emphasis on was.
No, it's a, what was it? It's a programmable extraction report language or something is what Perl was.
It's extraction retrieval language. I cannot remember what the P is.
But that, yeah, I mean, you could, every character in this language means something.
Yes. Well, it borrowed,
Very
from Bash. It
Bash,
borrowed from
sed.
borrowed from awk.
Awk.
It borrowed from, we mentioned sed already, SED, which is the serial editor.
Stream editor, I think.
Stream editor, yep. Which borrows from VI and ed, the original ed, with all the regular expressions and whatnot. It borrowed from C, and it has its own very own way of doing object-oriented programming by blessing. So there's no actual object-oriented programming in Perl. Okay, so every object is a hash. Okay, where all the attributes are basically just a hash. You say what is the counter? The counter is basically a map. So every object is a map. You can dynamically add members to that map and dynamically remove members from the map.
Temples like that too.
But the cool thing is but that's just a map, right? So how do you associate a particular map with certain functions that you can do with it? You bless it. So you bless a hash, a map, with a class, then those two things are now linked. So look up that word, bless, and Perl, you will start to learn.
Perl sounds
It's kind of like a super friend in C.
Yeah.
It's super flexible too. You can do things that you cannot even imagine doing
Have you
even
played
in
with
Java.
interfaces in JavaScript?
Hmm?
You played with interfaces in JavaScript?
Nope.
Same kind of thing. Yeah, all of a sudden you are now a descendant of this parent. Really?
And that can change in runtime, right? It's not a compile time thing; it is a runtime thing, which makes debugging and testing,
Interesting.
very interesting. Yes. Yep.
Perl sounds like the I made this meme.
Yeah, in Perl, if you use the wrong sign, like $1 versus % versus an ampersand.
Massive difference.
Yep.
And it's not a syntax error.
No.
It's just different.
Yep. Yep, but it's a very interesting programming language. A lot of practical use. Python is taking over. Python is taking over Perl at this point.
Stack.
But the other cool thing about Perl and also Python is it doesn't belong to any particular organization. No company owns Perl.
Larry Wall wrote it, right?
Sorry?
Yeah.
Larry Wall wrote it.
Yeah, it's a person. It's a single person who is actually in charge or steering the programming language itself. Now the other thing that's really nice about Perl is I have not found a single case where a newer version of Perl will make old programs do not work anymore. Now they do deprecate things. Okay, you can do a test to test an existing program. It will complain about, oh, this thing is deprecated, don't use that anymore, it's not good. but it doesn't make it fail, unlike PHP. PHP is well known to not only deprecate, but remove features within the same version. So if you look up, PHP 5, 5.8 will get rid of certain things to make any code built for 5.6 not work anymore.
I like what the head of Python calls himself. He calls himself the benevolent dictator for life.
And so Python has the same attribute as Perl, being that it's not going to make old code not work anymore. It's just that it will complain and say that, okay, this is not recommended anymore. This is deprecated. Okay, so getting back to testing. So when you're testing, it looks to me, I haven't really used it. So when you test it, it seems like you can generate outputs based on the mocked run of whatever you're testing. Then you can use the output to compare to whatever it's supposed to be. So you can test, you can conclude whether the program is doing what it is supposed to do or not.
Fire up Android Studio and play with it.
Sorry?
I said, let's fire up Android Studio and play with it.
Yeah, you have to import it too. So when you read the documentation, let me see where
it's like you passed it. It's how where it says the how to. First part of how to. Right there. Versus repository, yeah.
Yeah,
You
that's.
just add that to the Gradle. It's like build
Yeah,
up
but that's
Gradle.
not Android specific. Because Gradle is used in can be used in a lot of Java projects, not just
Right.
Android based. But when you look up the documentation, it will tell you how to do Android integration. But it still relies on Java code itself to do all the tests. So if you don't mind adding lots and lots of Java code for testing purposes, I guess it's okay. I personally like a data-driven approach rather than a code-driven approach, but that's a personal preference. So getting back to my notes, let's go back to my notes here. I can find out which tab. There we go. Okay. So my personal preference is to have this engine of testing built into the app itself. So you're not having a second program to test your app. The app itself has a particular interface for testing purposes. Now, how many people have some hardware experience where you understand that the manufacturing of a circuit board typically has what we call TPs or test points? So the test points, or special headers are for testing purposes. In other words, those are the headers where you attach a test rig to the thing, and the test rig will exercise the circuit board in a certain way to make sure that it does work correctly. So I'm trying to do the same thing with mobile apps where you expose those interfaces so that when you need to test a program, it's a data-driven approach. In addition, okay, so if I had to draw a picture, so typically, when you have a button, and also, let's say this is a list view, okay, and this is the core of your app, okay? So the core of your app is taking a click event, using the on-click listener to trigger some kind of operation. And that operation in return is going to affect the list view, so it's going to update the list view. So this is the usual way of doing things. It is user interactive, and which makes it kind of harder to debug because it's harder to test because you need somebody to be clicking the button, and then that person has to observe the actual change of the list view to make sure that the list view does look correctly. Is that okay? So what I personally want to do is to put an interface here and put an interface here. So in addition to having a button to trigger that operation, whatever this operation is, okay, so we'll just use a red box here to indicate the operation itself. So in addition to user interaction, we'll basically have a second way to stream in a data-driven approach to trigger this very same operation. In addition to updating the screen, it will also serialize the list view here, okay, and then stream this serialized list view to an output of some kind. Can be a log file, can be a TCP connection, okay, but this can be captured. So this way, your test rig, quote unquote test rig, is consisting of a TCP connection or two files, one as an input file, one as an output file. You present the input file, which basically will play back a sequence of click this button, enter text over here, click that button again, backspace a few times. It will play through, your app here, and then whatever your app is doing to the output has a concurrent output which can be switchable, so you can switch it off when you're not testing. But the switching is to enable, in addition to updating the screen, it will also have an output that is serialized. And whatever that serialized output is can be captured. Now you can compare the captured output with what it is supposed to be, and then you can automate the whole thing without using a separate program to test your program. So that's kind of my idea of how.
How do you handle the supposed to be? How do you handle the supposed
That part
to
still has to be hand driven, right? So that part still has to be handcrafted.
We haven't got that automated thinking part though.
No.
There's always some expected result we have to calculate.
Yep. Are you familiar with automated verification?
A little.
Little? Okay. So the idea is, eventually we don't want to rely on tests to see whether something is working or not. We want to be able to mathematically prove that something has to work correctly.
That's going to be the new thing in coding. Because if the code can do no other than it is intended, I guess you can't hack it.
Exactly. So if you look up automated verification, there are many names to this type of thing. Automated verification, formal verification is another name of the same thing. So this is kind of interesting because it relates to testing. But formal verification is not test-based. In other words, you're not trying to throw dots at the thing and see if you hit something that is not behaving correctly. Okay, you are trying to use mathematics to prove your algorithm that your program is working correctly. But it has to start with being able to express the correct behavior mathematically to begin with. Otherwise, there's nothing to compare to, when the computer goes through your code. Now, it's interesting in a way because formal verification was kind of really hot and popular in the 90s, okay, especially the early 90s. By late 90s, it's no longer talked about much because people thought it was not practical. But these days, it's making a comeback. Okay, so if you look up news related to formal verification, it is starting to gain momentum again. So formal verification. And we look up news.
Yeah, it's taken off in cybersecurity.
Yep. Because if you can prove, now you don't want to apply formal verification to everything because it is very expensive. Even with all the computation power today, it is still kind of expensive. But if you can just apply that to the core part of an operating system, it can make a difference already. So this is making a comeback, and I think the reason why it was abandoned, quote unquote abandoned, about 20 years ago, was due to the lack of computation power. So back in the 90s, we know that this can be done, but we just didn't have the computation power to do it, practically. Okay, so people just kind of abandoned the idea, go like, well, okay, it's kind of nice, it's a really cool idea, but we could not do it practically. But these days, with all the computation power that we have, it is now becoming semi-practical again. So when you look up, I'm trying to find out a link to news articles related to this. Okay, program verification, cyber warfare. Okay, let's see if we can find anything like that.
I found a nice one on it's on a Lawfare blog or something on emerging technologies, cybersecurity. It's about formal verification.
Okay, cyber security. This one?
Yeah, I think so. I mean, this one's talking about there's, you can only do it for previously for about 1,000 lines of code. Now they're up to about 10,000 lines of code.
Yep.
But I mean, I got more than 10,000.
Well, but that's why. So you don't want to apply this to things that are not important. But when you're talking about the SSH, the core of the SSH library, when you're talking about the core of SSL, then it's applicable because the actual core of those libraries is not that long. The actual encryption algorithm is not that long. Okay, so if you can apply this to the very most important core of networking or the kernel code, then it is practical enough because if that part is not breakable, even if the rest of the system is not secure, you still have a certain level of comfort knowing that okay, this part definitely is not breakable.
It comes from if you look up the Orange Book.
The Orange Book?
The Orange Book. That was like the first book on security. Orange Book security. It's gonna be. It used to use like the CM star property and trying to track.
It's not the Orange Book. Trusted Computing.
1983.
1980.
Go one down, you have the PDF version of it right there.
Oh, you don't want to read it.
You might.
I mean, this is understanding of computing back in 1983. They're not going to use the same language that we use today.
The Birth and Death of the Orange Book. Okay. But trusted computing is a whole different thing. But I guess this is the Orange Book, right?
Yeah, that's where we first started to even think about, wait, I mean, this could be compromised.
Anything can be.
And what we did is the fear they
It
had
will
over
be.
there was intense. We were tagging bits as we wrote them down because we had classified data. We wanted to keep track of it. We were trying to figure all of that problem out. We went down this rabbit hole. It was Alice in Wonderland by the time we got out. It's back along with all those power on self-tests when we used to think we had to, extensively test every bit of the computer before even thinking about using it. Now we don't worry so much. They're much more reliable than we are.
Well, but it's still written by and designed by people. That's what part of the issue. If you work for the national labs, like the Lawrence Livermore National Lab, you cannot bring your cell phone in. You cannot bring anything USB in. They will check you, before you can get in. Depending on your security level and which part of the lab you're supposed to go to.
First you cross the fence and you have to show your badge. Then you cross the entry to the door. You have to show your badge and dump all your stuff. Then you have to show your badge again with the guy with the gun to get inside the cipher code in the door.
Exactly.
And then you're locked into this dark, dingy room, and you spend your life
there's
there
still
with
one more
8
door,
other people
and there
working
you
on the
leave your
same
soul.
project for 3 years.
Yep.
You get into the last door, you show your badge, and give him your soul.
So if you think about it, mobile devices are not very secure. Okay, if you just pick up an Android device from a store, it's not a secure device. Because Android itself is not necessarily secure. It's not hardened. Okay, it's not hardened in any way. Well, I guess it is because it does have SE Linux enabled. So it is quote unquote hardened a little bit, but not by any actual level is it secure. And on top of that, some of the Android devices are manufactured in China.
And then
China.
the software in China.
Yep. Okay, so if it's manufactured in China, then potentially things can be.
It's already compromised.
They can build these adapters, and the data that moves across goes another way too. Instead of testing, they just.
Or have a built-in chipset that can emulate Bluetooth. I mean not Bluetooth, but USB devices. Okay, because we kind of talked about how USB is kind of tricky, because when you look at the USB port, you plug in something, you think you're plugging in, let's say, a camera. Okay, but it can have an internal hub. So in addition to the camera, it can also be a USB mass store device. It can be a USB networking device, or pretending to be a networking device, but it's not actually networking. So it would talk TCP/IP to your computer, and say, hey, hello computer, I'm a new I'm a new network card with an older chipset, so it's well supported. Okay, and Windows, upon detection of a new NIC, what does it do?
It
You-
auto installs.
Installs
It will try to install it, and then what else is it gonna do?
Use it.
Yeah, I want to use it. Okay, let's figure out who's the
Victoria, let me
DHCP
use it.
server.
What's over there?
What is my IP address and so on, right?
Mm-hmm.
So what if that is all fake? It's all
Your
emulated.
system is now
Right?
compromised.
Well, I saw in the news that they were, I mean, now at the airports, or they, in the latest version of Android, when you plug into a USB connector, like at the airport,
Mm-hmm.
that never told you that what you were connecting to. Now it'll bring up a message saying, do you want this connection to have access to your device? So.
I thought that
I mean,
has
you-
always been a menu. Whenever you plug it in,
I mean, I
or-
wasn't an Android person, but I mean, I was always worried about sneaking into any, connection port. You have no idea where you're going.
Yep.
It says you're just connected.
It only shows that, it doesn't show that if you just plug into like power.
Yeah, because a power doesn't talk USB.
Yeah.
But if you plug into anything that talks USB, it
Right.
will pop up a menu and go like, okay, what do you want to do? And the default is charge only.
Yeah, by default, that's what they do now. Is it
Yeah.
doesn't
Well,
even
unless
prompt
it's
you.
made
It
from
just says
China.
power only.
And they have a doorway, right? I mean, you have no idea what's going on inside Android.
Yeah, mine's running the latest Android and all. It just by default it just says power, and then I have to manually tell it,
Right.
okay, do this
Mhm.
instead.
Yeah, but
Fixed
for the
that a
longest
while
time,
ago.
yeah, for the
like
longest
that.
time,
They had to fix it a while ago.
Yep.
At the very beginning, people were just doing it, was my point. It's
Yep.
like they had no idea what was happening to their device.
nope. Yep, and the same thing happens to Windows too. The scenario that I just described. You just hook up a Canon, point and shoot camera to your computer to download a few files. Okay, if it pretends to be a network card at the same time, unless you're looking at the notification bar and pay attention, you won't even notice it.
Which most people won't. And they're just like, oh,
I can't
it
slow
just
my way
recognizes.
down. Warning, dialogue dismissed. She's so fast.
Wait, don't touch that.
Yep. Well, that's the thing about Windows is they made it so tedious that people
Nagging.
just ignore the message.
It was a nagging operating system.
Yep. Which
It still is
defeats the whole purpose. But that thing, anything that is USB based, potentially has issues. Okay, and then Bluetooth can potentially be the problem too. You have a Bluetooth headset. Is it really just a headset?
What is the headset?
You
Not
don't
just
know
the
because
headsets.
because now it is even more obscure because it's wireless. Okay, you're not plugging in anything, right? So you're just making that connection, and is it really just a Bluetooth device, or is the Bluetooth device also trying to pretend to be something else that can potentially be used to hack into your operating system? So nobody knows, how many zero-day exploits are actually floating around internationally and just waiting to be deployed. Nobody knows.
Yeah.
The CIA has a whole bunch. Okay, the Russians, may have a whole bunch. The Chinese may have a whole bunch.
And they had some.
So, well, getting back to testing, but a formal verification is a concept that some of you may be interested in, okay? Because it's mathematical based, so it's kind of the cross between computer science and mathematics. It's not just programming. There's a lot of math involved as well. But it is now practical to be done again, and there are actual applications. Because back in the 90s, people really do not worry that much about cyber attack. Because even though the internet was around back in the 90s, it did not really get the recognition that they got today. I think when did Bill Gates when did he say that the internet does not matter? He said something along that line.
No, Son used to say the network is the computer.
Sun was way ahead of his time. Yeah, Bill Gates, ignore internet importance, or something along that line. Okay.
The biggest photos of Bill Gates.
It may be 95.
Didn't
Bit.
it save the world?
see, Vista, Windows 8, Windows 10. Those are at least 3 of his biggest fails.
Mm-hmm.
Millennium.
Well, Millennium was okay. It wasn't as bad as Vista 8 or 10.
But it was in the 90s, for sure.
True.
Yeah. Okay, go
I think that
away.
one didn't even have internet support initially, if I remember correctly.
The worst one was DOS 4, I think.
That's a terrible picture.
Oh, yeah.
I still have nightmares about DOS.
Double space just blew away my whole C drive. Just everything was just gone. Okay.
I
Or
still
didn't
have
last very
nightmares
long, man. That
about
was one
DOS.
dangerous operating system.
DOS never even knows what it's doing.
But anyway, even Bill Gates, said the internet was not important. That was in the 90s. Because, the internet did not get, well, most people did not, there were not a whole lot of resources on the internet in the early 90s. It was
The
until
universities.
just the universities. And people do what? They play NetTrack. They use Mosaic, which is the early day browser, which was awful. They just look up certain things, and there wasn't really a
Wasn't
whole lot.
Netscape first?
No.
No, it was Mosaic.
Mosaic.
Mosaic was the
Yeah.
They're
first.
still here.
No.
Mosaic has not been around for a long time.
Mosaic had like one version. It's the godfather of browsers. So the people who worked on Mosaic go on to do
What was his name?
Netscape, though, I think.
NCSA. What is NCSA?
Oh, National Center for.
Computing application.
Okay.
1993.
But back in those days, all the web pages are mostly, text, with very few graphics because the internet was slow at the time. Okay, so the internet did not penetrate to households. Okay, people were using modems at the time to connect to BBSs, bulletin board services and stuff like that. But for the most part, people did not have access to the internet. And now your mobile device is always connected for the
Yeah,
most
they were
part.
close. Initial release for Mosaic was January 23rd, 1993, and
Mhm.
Netscape was December 15th, 1994.
Okay.
A year later.
Possibly, sharing, developers too.
Yeah.
Because I can only imagine that there were only like a few people back in those days, working on browsers.
What was his name? Microsoft wanted the browser, and he wouldn't.
Yeah, it was
he
later.
wouldn't give it to him, and all war broke out, and
Yeah.
and he totally lost his company to.
Yeah,
Oh,
and,
Bill Gates.
Mosaic event is technically
Mark Anderson.
is technically still around. It became Netscape Navigator, which then became Netscape, which became what was it
Firefox.
Thunderbird, and then
I
Firefox.
guess Microsoft licensed it to create an Internet Explorer in '95.
Yep.
That was a wonderful browser, wasn't it?
Especially with the ability to run native code directly. What was it called?
Oh yeah. The,
Direct access or something like
not
that.
not the object linking embedded. Was it ActiveX?
ActiveX. Yeah, that was the.
Yeah. Hey, I'd like to access your computer, please. Sure.
Well, that was for the longest time. That was the reason how Microsoft hung on to Internet Explorer because they got the market share to begin with. So by convincing content providers and say this is a good idea because you get to run any code you want on the client computer, they were able to stop Netscape and all of the other browsers from getting into their market share because they could not run native code. So if your website has native code, necessity, you go like, oh, we need to do this, to make it look nicer and whatnot. The only way to do it is Internet Explorer. You cannot use anything else. So that was a mechanism to lock in their, the browser along with the operating system.
And they did that, and that's what they got sued for, right? I mean, they basically.
Yep.
They basically killed the concept for their embeddedness.
Yep, and the Europeans did not like that at all.
Mm.
They ditched Windows, just because of that. But the point is, back in '93 or so, the internet did exist, but for the most part, it remained as a resource that only large companies and universities have access to. It is only until 2000 or so that the internet became available to just the majority of households. Okay, so the issues related to the internet did not get recognized until much later. All right, so getting back to testing. Oh, this is also kind of interesting. For those of you who are going to publish your app, and you want to roll out new features and whatnot, you might want to look at this approach too. So you might want to look at Fitbit, roll out sleep. They call it sleep stages. There we go. Okay. So the thing about Fitbit is when they have new features, especially ones that require quite a bit of testing to make sure that things are working correctly, they do not just release the feature. They roll it out. So let's say you have a customer base of 100,000. Okay. So what they would do is, I'm not sure whether it's random or whether they have a particular way of selecting who gets the feature first to be the beta testers, but they will only release it to like a small number of people. And then based on the feedback, they will do the bug fixes and whatnot. And then as they gain more confidence, they will roll it out to more people. So my Fitbit, did not get sleep stages until like 2 days ago. Even though that feature was available to some of the users in March. So they took an entire almost 2 months to roll out that feature increasingly to their user base. So the upside is you have more time to debug. Instead of upsetting 100% of your customers, if it doesn't work, you'll be upsetting 5% of your customers. Okay, and you have a chance to fix it. But the problem is a lot of people really, really wanted this feature, and knowing that this feature is already out, but they're not getting it, a lot of people are feeling pretty upset about it. A lot of people actually plan to return their Charge 2 devices because according to the Fitbit website, they're supposed to have your sleep stages, but it's not it's not out there yet. So there are pluses and minuses with these gradual rollout of new features. So you might want to consider that if you're publishing your app.
Well, I guess the bigger challenge with not just rolling out is moving our data forward in our app.
Mm-hmm.
I mean, we're responsible for everything we do today, and promoting that forward for every version, or some of our users are going to be a little bit upset. I mean, at least for me on the content. I mean, if I do an app update, I can't lose what you stored in the app yesterday.
So that means you have to plan ahead of time. The way you would store and represent the data has to be forward compatible.
Almost from the first version.
Yep.
Or that'll be the first customer you get a bad review from. Nice update, I just lost everything.
or you have to supply a way to convert. Like, this is the old way, this is the new way. And that's why we saw that. We did see that with database, because you can there's the engine that reports back and say the database itself was using this version, but the app is this version. And
that's only the database.
That's only the database, how you represent the data. That is correct.
Oh, I mean, so just as building mobile apps, I mean, to be very specific, I mean, I guess it's the same for every app, but that would be a large challenge.
Well, for the most part, if you change the user interface, it will, upset a few people. Every single time you update the user interface, even if it is updating to a better user interface, it will still update, it will still upset a few people.
Oh, of course. It's just a matter of what percentage.
There's another one called Espresso, I see, too.
Yeah, there's another one
Espresso?
for testing.
Yeah.
Yeah, there's one called Espresso. There were a few options.
Espresso's on the developer page.
Yep.
So it looks like you carry the code with you.
So provides a set of API to build UI tests to test user flows within an app. These APIs let you write automated UI tests that are concise and run reliably. It is well suited for writing white box style automated test. So for those of you who don't know what is a white box test, a white box test is basically one test that assumes that you have access to the source code. You know how the thing works in the first place. A black box, on the other hand, is only testing from the outside. You don't know exactly how it works in the inside, but you are only exercising the user interface. So for view matching, expression on view method let you access a user interface component within the target app and interact with it. It uses a matcher argument and search the view hierarchy. So this is done at runtime dynamically to locate a corresponding view instance that matches some criteria. So this is done at runtime. Basically you have a mechanism at runtime dynamically. You can examine the content of your views, of your user interaction components, and see what is actually in it.
So if we touch a button and we're supposed to change the text, this guy will verify the text has been changed.
Right. Or at least find out what it is. Then you can do the comparison or do whatever you want.
Versus like yours up here, that button, you'd have to work harder to check to see if the button changed its text.
Right.
But you do know that the result was correct.
Right. Now this is only possible because of Java, because Java as a programming language allows the engine itself and also allow the libraries to have access to the individual components.
It's called reflection.
Reflection? Okay. Reflection is also a concept in discrete math.
Yeah, this is when the class tells you about itself.
Mm-hmm.
It's reflecting all the things that are inside of it or something. I believe it was called reflection.
Yeah, C++ doesn't have it. C++ just gives you an offset. Oh, you want that attribute? It's this many bytes away from the beginning of the structure. That's all it can remember. What is it? Don't know.
And it's a virtual pointer. Okay.
What is the
jump
name of
to
that?
it.
Don't know.
It is the memory of a goldfish.
So this is possibly one of the better ways of doing tests. So if you look into thread synchronization, UI automator.
So if you go up just a little bit,
Mhm.
yeah, you got it right there. On view, go grab the button and perform the click.
Okay, type text into an edit view, then close the soft keyboard. On view with ID, perform. Okay, so you're injecting changes to the user interface element, and then the next one is to press the button on view with ID, perform click. So you select what you want to do, which component, and then you can say what to do with it, and to emulate the end user actually doing it. But what about checking the content of that thing? So these are actions, adapter matching. I guess in that case you will still have to access the dot, get text, to know the text of the button. So it will still be Java code driven. It's still a code driven approach to get it done. But it's a big topic, if you look up test engineers, in software development, it's a very niche kind of job, and very few people are really well equipped to do it. And the worst person to do testing is a developer. The developer of the app that is being tested, never rely on that person to do the tests.
I do a good job.
In general, it's not a good thing. Why?
It takes a long time to learn how to test your code.
You have to wear a different hat. You have to think differently. You do not want to, because the biggest problem is if you miss something when you're coding it, you will probably miss it when you're testing it. That's the biggest fallacy of having the same person to develop and also to test what that person has developed.
You assumed it should work like this, so you test it to work like this.
Yep.
And it's wrong.
Yep. Exactly. You're using the contractor to also be the inspector of a property. If the contractor missed something to begin with, honestly, that person will honestly also miss it in inspection. Okay, so it's not like the person is trying to lie or there's any type of malice involved. It's just if you miss it in the first place, you're gonna miss it again. So that's good to use, or good to know at least. So these two are supported by Android and also Android Studio. The UI Automator is actually supported by by Android Studio. I have not used it before. I haven't really used any one of these. But this may be something that you might want to look into if you're actually going to publish your app and want to be able to test your app in a systematic way. The expression test recorder, from just the name of it, means that you can do something interactively, manually, and it will record it and play back next time you want to test it again. The question is, how does it know whether the program or the app is working correctly or not?
And when you change it and you rearrange things in the middle of the test, can you still use the recorder?
Yep.
I mean, the playbacks. You deleted that button. That
Yeah.
text box is gone.
But the problem with a recorder, even if you can record both the action and also the reaction, if you're dealing with something that is database based, that itself is not enough of a test, because if you have stored additional things in your database, the correct output would not be the same anymore. So the approach of just using a recorder and just going like, okay, is this app doing the same thing as it did before? It's only going to work if you have the same initialization. Okay, but if you're trying to use it on different type of setup or different initialization, then it won't work anymore.
So we shouldn't use random numbers to generate tests.
If you use random numbers, then you
It's
need
not
to
repeatable.
programmatically figure out the correct answer and then compare the output of the program to the expected answer. So that's the only way to do it. And then you have to test that particular code to make sure that it is correct, right?
Never ending.
It's never ending, and that's why we have all kinds of problems.
It's just turtles all the way down.
Yep, turtles all the way down. And the biggest problem with Android is not just the apps may have bugs and whatnot.
The next version of Android may have a bug.
It's the drivers. For the most part, the drivers are the big issues. Because the kernel code, which is Linux-based, is fairly stable, and a lot of people have seen it, and critique it. The driver code, on the other hand, has not really seen a lot. Most people have not seen the driver code because it's not open source for one thing. So if you look at Qualcomm, all the chipset code, all the driver code, it's Qualcomm code. It's not open source. So that means not a whole lot of people have actually seen the code. And those problems are very deep as well, okay? Because it's not just the app itself not working; it's some really crucial part of your program not working. All right, so I'm gonna go back to my slide here. Okay, so we got a few challenges. Sensors can basically be the same problem, because if your app is one of those things where it's kind of hard to test because it relies on the sensors too.
Yeah. Gotta turn that part off.
So you can either emulate the sensors, basically you can pre-record when you're actually doing it, record the sensors reading as well as the timing, because the timing plays an important part as well, right? How still can you remain? That becomes an issue. So if you can record and play back and you can inject.
Those are better classes tested offline.
Hmm?
I mean, those are classes better tested offline. Using a slight bit of separate inputs to determine the logic anyway. Because I have a high pass filter, a low pass filter, a smoothing, and I've got all this stuff in there in order to. Right? I mean, you you would have to have it on your sensors, and so that way I can determine acceleration and flatness and orientation. But I wouldn't want to try and, I don't know. Once it does its job and reports it's flat, then it shuts the whole app down in a sense. So I test that separately, and then go through all the rest of the functional testing. All right, there's a real user here. That's it.
But how do you test energy use of your app?
I watch the monitor and make sure my CPU goes flat.
Okay.
So I use the monitors, and I found out everything that's on, and I can see that there's any activity, and cut everything off until I'm flat. And it's still, I think I'm still like, I can see a little bit of color when I pull the whole thing up.
Let's see an example app.
Example app.
Yes.
On what?
Okay.
How to test.
Well, but this is the most difficult one. I really have not figured out, how to test
Multi-threaded
the
testing.
interaction of threads. I came from a embedded system programming background, and this remains as one of the most difficult things to test and debug. is the interaction of threads. If you Java may not be as bad, but with C and C++, if you can have a program working perfectly, and the moment you turn on optimization, all hell breaks loose.
But it runs if I put my debug statement in it.
Or if you just run it, or if you
Put it in
compile the
declining
program
mode.
with a dash uppercase O0, it works perfectly. The moment you throw in any optimization, it goes like. That's because of the incorrect or not using volatile. In C++, Java doesn't have the concept of volatile as far as I know, which is an optimization thing.
That's a variable that can be changed outside your scope, right?
No, it is within the scope,
So
but can it be
register
changed
it?
in the background?
Right.
That's the question. Can it be changed without in the background? So if you say something, if you don't say something is volatile, then the compiler assumes, okay,
So
so
you can throw it into a register and keep using its local
exactly,
value.
yep. So if you say x equals blah blah blah, and then down here you say g of x, okay? And if you do not declare x as volatile, then the compiler says, oh, okay, so you're assigning something into x, nothing happens in between that you're using over here. So if I store whatever is on the right-hand side into a register, for instance, or something that is, something that's not in memory where x is, okay? I can just use that register in this context, okay? But now the question is that really true? Because if x is a global variable, and you have interrupts happening in the background, or if it's visible to other threads of the same program, then x can potentially be changed. But if you do not let the compiler know that x can be changed in the background somewhere before g of x, then the compiler will do the optimization and be smart and go like, I don't need to store this into memory, which is expensive. I'll just put it into a register because we have enough registers, and then use the value of the register here. Okay, so the optimization, is causing the problem to show up because of the lack of volatile. I have seen programmers who just basically make everything volatile. You can make subroutines volatile, by the way, in C and C++. Yep.
Just because you can doesn't mean you should.
No,
You can
sometimes
make-
there's tools for everything.
You can make a
Those
whole
last for
subroutine
everything.
volatile. Okay, so in C++, volatile, subroutine, member functions. Okay, so it only applies to, well, no. Yeah, it only applies to member functions of an object. So when you declare a member function to be volatile, it just says, it can change, things in the background. Or,
Oh, it can change things in the background.
right. But I have seen people just throwing volatiles everywhere when they have these unexplainable bugs. But threads can be an issue because you can have threads in an Android app.
Oh, absolutely. You should
And-
have threads in your Android app.
Well, it
If you're
depends on what
using-
you're
if any
doing.
long processes
You need
that
them.
block you.
Yeah.
Yep.
If you need them, you should use them.
Yep. But the bugs related to threads are very difficult to spot because they only happen once in a while, and when it does happen, when the symptom shows up, it is already way past the point of the actual interaction that is not supposed to happen.
Right, because when you use the wrong variable, then later on something breaks.
Yep.
But it happened way back here.
Yep. And those are the really, really difficult bugs to fix, or to detect, or to log.
They're easy to code.
They're easy to make. The mistakes are easy to make. Yes. Yep. So anytime you think about using multiple threading, you kind of have to keep this in mind, because it is much better to be cautious when you're writing the code and you think, okay, can this thing be accessed from multiple threads? Do I need to make sure that it is synchronized? So you have to think about that ahead of time.
I've seen a lot, I mean, in my experience, not a lot of areas programmed that way, even with multiple threads. But now I see in the cloud stuff a lot of worker rules, which are just clones. They're clones. They're not really interacting.
Mm-hmm.
So that way they can multiply the use of cores, stamp that stuff out. But the multi-threaded programming is easier because you're really just cloning workers of the same, like tellers. So they just create lots of tellers, but they don't really interact. That all happens in the background.
They're
and
basically
and the
solving
key
a
banking
smaller
environment.
part of the bigger problem, but they don't need interaction to get.
Yeah, they want
things
to use
done.
the hardware, but they're not doing a very good job.
Ah.
Right? I mean, if you had a better one, you'd say, I'm servicing off a queue, I pick up messages, I do processing, I respond, some other thread picks up, now we're all running and the queues stay lightly balanced and the data's flowing.
But that's the kind of code that has high interaction amongst the threads, which makes it also very susceptible to this type of thing.
Absolutely.
Yep.
It's the good stuff.
Well, that's the kind of code that takes a lot of time to debug.
Not really. You just got to code it right the first time.
Yep. Well, you would hope.
If you
would
can't
hope.
code it right the first time, you're going to be debugging for a long time.
Well, but that also it boils down to who is writing that code. People who are aware of these problems probably will try their best to code it right the first time. But there are people who did not even know about issues of threads interacting, corrupting members of
When you're
an
learning
object.
about a critical section the hard way. Yeah.
But critical sections are
There's just
only
people like
discussed
Walk the World Run.
in the operating system class at a 4-year college, and that's an upper division class. So when you think about how many people who have not gone through a computer science program in a 4-year college, and they're trying to write apps because they learn how to write apps, using a book, using one of those 12-week courses and whatnot. And they look at some code, we can use a worker thread this way, and they started to use multi-threading. You can just kind of imagine the kind of trouble they can get into.
Yeah, their app crashes.
In random ways and unpredictably.
On different hardware. And then a lot of them might have like a simple, slower phone, and they might not experience it. And then they get to you guys as octa-cores,
Yep.
and all they get is bug reports.
Yep.
And how do you get your app back in the store when you really have to go spend all those debugging hours to figure
That
it out?
reminds me of Pokemon Go.
Oh God.
Now that seems like ancient history. Do people still play that?
Well,
They must.
I'm still getting updates of new features of Pokemon Go.
I've considered playing it on my new phone. I quit. I had one of the Mews, and I quit when they reset everyone's account.
But me, in the older version of Pokemon Go, me and also my friend, noticed a pattern. When there are things happening at the same time, it crashes. And you have to
God.
restart the app.
And if you're lucky, you get to log in. I remember when
I
it
stopped
first
playing
came out.
games after Tempest. You ever see the Tempest video game? I mean, I used to play video games all the
I've heard
time.
of it. I don't remember.
It was young. This was many, many years ago. And then I was like, I'm sleeping, and all I can do is play
God.
Tempest. And I realized I don't have enough bandwidth in my life to play games anymore. Just stopped. It's like having that song in your head when you're trying to code.
Tempest?
That's
Yeah.
Song by the band Tempest?
No, it's this little thing you had to run along the outside and shoot all these things that are coming up at you.
oh God.
Probably.
That's so familiar. I'm looking it up.
This.
Yeah.
Yeah. Oh
Don't
God.
even
Yeah,
show
I
that
played
to
it.
me.
I've played it.
I put so many quarters into that machine, my brain was fried.
No, I played it when it came to computer. There's an emulator for it.
I don't even want to see it anymore.
Write an app
It's-
for it.
It's burned into my brain. I probably still remember all the levels.
Yeah, you could probably just program it into Android for memory.
Turn it into an app.
Bugs and all. Bring out the voodoo dolls.
Just a few things that I want to kind of point out. Android, mind, reading.
Oh God. No. No.
It's actually a device. Okay, mind reading. Okay, maybe not Android. Let's try Bluetooth. Maybe not be under this mind control. Okay, mind, not mind reading, mind control is even worse. There we go. I think they sell it as a health device. There are multiple devices. Okay, they're Bluetooth based. You just wear a little headband, and they can tell whether you're anxious, whether your mind is calm or not. So these things are selling like hotcake. So for those of you who want to kind of venture out and go like, okay, what can I do with mobile apps and whatnot,
I'd like to put that on a golden retriever.
golden retriever.
Or any of those other really hyper dogs.
Golden
See what kind of
retrievers are
reader-
not hyper. They're not. They're typically pretty docile compared to other dogs.
There's one I'm thinking
A
of.
dog's life is determined in like first 4 months of its life. If things made sense, they're confident and they go forward. And if they didn't and they couldn't understand why they got locked up and why this happened to them, they're gone down a horrible path. And they get anxious.
I think people are the same way too.
Yes.
We probably are. It's those. I guess in the philosophy, the young, that first few stages are really critical.
Mm-hmm. Okay, I'm trying to find. Oh, there you go. This is the thing. A reading mind device. This is in Pinterest. Doesn't that look like the thing in the Star Wars toy?
Yes.
Yep. So there are a few devices like that.
I mean, what's it called? Isn't it called the X Factor or something? You can't monitor something without disturbing it. What is that one? I mean, you gotta wonder what's going on here.
It's in quantum physics, right? That's a quantum physics
Yeah,
thing.
yeah,
When you
talking
observe
about.
something, you're changing it.
Yeah, you can't
Yeah.
observe it without changing
Yeah.
it.
At least changing the nature.
So,
of it.
I mean, a lot of people don't. I mean, with this stick thing to your head, I'm gonna wait a few years.
There's actually another device where you clip two things, in your earlobe, onto your earlobe, and it sends a very small electrical signal to kind of change your mind, mood, and stuff like that. And there are homemade devices like that too. People just use a 9-volt battery. It's a therapy. It's a form of therapy, like psychotherapy, where it's not a shock. You don't really sense the shock, but there's a very small current passing through your brain. And some people claim that it helps, improve, concentration and whatnot. And some other people say there's no change whatsoever. But in the previous class, we did talk about how your brain is mostly chemical based, and not electrical based. So, I would really doubt that it actually has
You
any
need to
effect.
stimulate the chemical producers.
Unless you can do that, but a DC current is unlikely to actually do that. If anything, it's going to be an AC current or something that is with a pulse nature, instead of a DC, just continuous type of thing. But this is where things are going. I mean, you can also find devices, Bluetooth devices that can monitor breath. Okay, so monitor.
Yeah, this has been the thing that's been missing in all the technology so far is the sniffers. Why can't I stick my phone up next to the tree and know what dog has been there? My dog knows, right? But there's no sniffers in all of this technology.
I'm still waiting for
They are starting to
smell-o-vision.
make sniffers, but not for dogs, but they use it for bombs and whatnot. Basically they.
But they're very, very narrow band.
Yes, they are.
They're only looking for a small thing. It's like that major biotechnology is completely missing in our digital world.
Well, they don't have any way to manufacture, hormones either, digitally. I think I need a little more stress hormone. Give me another, shot. Yeah, but they have a device, where you can wear on a belt. Okay. And it's basically just a accelerometer. It can monitor your diaphragm movement, and as people get nervous, their breath pattern changes as well as their heartbeat pattern. So there are devices like that, but these are all potential things, that can, be an application of an app. You're just using your mobile device as a terminal, and also as a login device, and also as a device to hook up to the cloud. But most of the analysis, most of the data collection, and also the analysis is happening in the cloud. So you can reinterpret things that you have been collecting over time, and give the end user, insights, suggestions, and what to purchase next, you might be interested in this medication.
Well, didn't
Well,
Facebook just say they're not pitching ads based on the emoticons you use?
that's not the only bad thing they've done.
Yeah, you start using the emoticons, you start pitching your mood, so they pitch ads based to you whether you're happy and sad.
They don't have that. When I went to Hawaii earlier this year, I got a T-shirt. Oh, I didn't buy it, but I saw a T-shirt that says beer maybe for you, and it just used this say the usual legal talk with any type of medication. So they talk about the potential side effects of drinking beer, but in a very funny way. It was actually pretty good. Beer maybe for you. Ask your doctor about it. Side effects may include, and it's a long list of hilarious, side
And
effects.
death.
Yeah.
I guess maybe tequila, maybe.
I'm a cheap drunk. I cannot metabolize, alcohol very effectively.
If you keep practicing, it gets really easy. But you pick up a different alcohol and you can't metabolize it like.
But
you
alcohol is
can.
alcohol, right?
I don't think so.
No.
I can drink certain things, but then I switch
Not
to one of
all
those other
alcohols are
spirits,
the
and
same.
I'm surprised how far it'll knock me.
Yeah.
But anything will knock me, so I'm not
It'll knock
surprised.
you down a
that-
few turtles.
I once went to the there's a pub, not a pub, but they make their own beer in Davis, and I ordered a cider, okay, and I couldn't drive home for 4 hours.
Yeah, I mean, if you've never experienced it, I think your liver doesn't know what to do with it. It's never seen this particular chemical before. But after it starts to figure it out, then it can start to neutralize it faster.
Hmm.
It's like, what the fuck
Possibly.
is this?
Pretty soon you're drinking vodka at lunchtime going to work. Technically, you should be drunk on your, but you just don't realize it.
Nah, it's just breath, freshener. Mouthwash. Alrighty, so I think we're done for today's lecture. Are there any questions from your
When do we start
apps?
the lecture?
Sorry?
I said, really, when do we start the lecture?
Well, we kind of blend the lecture into the other things, but we did talk about testing, which is the main topic of today.
Yeah, test your app.
Testing your app, for your homework assignment, I don't expect you guys to build anything like that or utilize all the tools to do it. But over time, as you become a developer, you need to kind of think about the framework of testing your apps, and that's going to be a big question because battery just went dead.
Oh, class is over.
Class is over.
Test early and test often.
Yeah, but testing is a big thing because that's the number one
It'll
reason
make you a
why-
better programmer if you can write tests. It's coding again. You got to code and test. You have to think hard, and it'll improve everything because you'll realize,
Write
wow.
successful tests. Now that's a real challenge.
But when you're thinking about how to test your app, you are actually getting a second pass of your code. You're thinking about the app again, but from a different perspective.
Yes.
Just by thinking about how to test your program may catch certain things. It's like, oops, forgot about that.
You got to think about what
Exactly.
you got to test what you think is going to work. Then you have to test what you think shouldn't work.
Yep.
Exactly.
And also you have to think about what is the correct behavior of your app, which you may not have thought about.
Yes, this is true.
Yep. When you take programming classes, it is not uncommon that someone may turn in a homework assignment not knowing what is the correct output. Okay, so they're
You
not
might think you're
asking.
developing
They're not
soundboard app,
asking.
and you might actually be developing a beatbox app.
Yep. Well, it is not uncommon because I have seen cases where people ask me about the question, how do I fix my program? Okay, so do you know what your program is supposed to do? Because that is the main question. Okay, if you can tell me my program is supposed to do this, but it is instead doing that, then we have a starting point. But if someone cannot even tell me what the program is supposed to do, like this is supposed to be the output, but I'm getting this instead, then we don't have a starting point. And I'm surprised sometimes, how often I encounter those situations.
Well, I view programming like skateboarding.
Hmm?
Programming is like skateboarding.
I don't skateboard.
Well, and for many Tysons, people don't program, right? And so some people look at the skateboard and say, "I'm not getting on that thing." Some people that get on it and maybe they can go a little ways down the road. Some people can even curve and drive. They're not so bad. They'll actually get a job. And then you see the guy that swings out of the swimming pool, flips upside down on the board, lands back down again, and you can't figure out how that guy did it. You know, and that's what happens in software too.
And then you get the guy who thinks he
you
can do
leave the
that.
set of rules, you do what you need to, and you come back down again.
And then you get the guy who sees that guy doing that and thinks he can do it too, and ends up just falling on his ass.
Yeah, so I'm not really referring to the skateboard. I'm just saying the level of complexity, and then the person that can master it. Hey, flip my board, not a problem. You're like, I can't flip my board. I can't flip my board. This guy's, I'll flip the board while I'm rolling down the sidewalk. Not a brainer. You know, and so programmers transcend, and some of them are that good.
Mm-hmm.
You know, and you find them at the core, like a Larry Wall or
Linus Torvalds.
Linus Torvalds. You know, all these guys that are down there just doing the magic.
Well, but a part of that is aptitude as well. Aptitude plays an important part when it comes to programming. You know, hard work important, but aptitude is just as important.
I don't even code until I know what I'm going to do. I mean, I sit there and I'll think about something, and then it'll come to me.
Yeah,
and there's
kinda
very
feel-
little code to be written. So why are people sitting at the computer banging out all these things that don't work?
Because they're using a trial and error approach, which typically works in many other things in life, but in programming it does not.
No, don't be like
Unless you're
1,000
testing it, unless you
monkeys.
want to bang away at an interface to figure out how it works. Then that trial and error goes really handy.
Now, IBM is one of those companies where they don't really do anything unless it makes sense, especially if they keep doing it for years. This is if you can look it up, just use a Google search, use the same words that I did, IBM Programmer Aptitude Test. These are photocopies, or pictures of those tests. They are kind of like IQ tests. They're not word-based. It's not like a story. After you read a story, you have to figure out, does John like Mary or something like that. They're all picture-based. They're looking for patterns. And apparently, the IBM aptitude test is very, very accurate when it comes to trying to figure out whether someone is going to become a good developer or not a good developer. Because you can go ahead and find out and what kind of test. It's just what is the next number, okay? And in this case, what is the next object, the next pattern, the next picture. So it doesn't involve words, okay? You can. Some people may not even know enough English to read the instructions, but they can still look at the pictures and go like, oh, that's going to be the next one. That's going to be the next one, and so on. So this is an aptitude test, which is kind of interesting because we get advice from all kinds of people, saying that grit is the most important thing. It is the attitude that is most important. Well, those are important. Without those, people can only get to a certain level. But aptitude is actually important when it comes to developing code, mathematics, and stuff like that.
Oh, for me, I wouldn't have been a coder if it didn't work the first time. After a while, most of your code should just work the first time.
Should.
And then you're a programmer, right? I mean, if not, you're going to sit here and you're going to bang your head up against the wall. You're not going to save yourself any time, and you're still going to have to think about it and then say, "Oh, okay, now." And we used to fall over on the floor when I finally realized what I did.
I'm a
You can see
sloppy
it.
person to begin with. I make careless mistakes all the time, so I cannot make programs work the first time. But what I'm really good at is finding out what's wrong with a program and fixing it. And I can do that to other people, the programs of other people as well. I can look at a program that is not working, and then just work
Run
my
it
way
in your mind. You
back
got
up.
a good mental sequence diagram, code, changing all the
I
data
reverse the
structures.
sequence. That's what I'm good at. It's
Yeah.
reversing the sequence, not going forward, but going backwards.
And detecting the pattern when it happened.
Yeah.
Because I can see when something happened, I know like the last 10 steps I took to get there. So I let me try that again. Oh, look, it broke. Or that's not what
Yeah.
it was.
So to me, programming is not about how many lines of code you can crank out per day. To me, it is how many problems can you solve, how many bugs can you fix, without introducing new bugs.
And honestly, please don't write a lot of code. Write as little code as possible. Then you don't have to test it.
As opposed to people who like to copy, paste, and
Copy,
modify.
Pasta.
And then they don't realize they didn't change that index. And there's no problem with the variables. It still references a variable because it really was there. You were supposed to change the name of it.
Now, if
That
you-
is-
Exactly.
But if you want like double barrel, then you combine, copy, paste, and modify with global variables.
Yes,
That
see,
makes
I
a
can't
lot
function
more
like
fun
that.
compared to
It's
not
absolutely.
using global variables.
Me, I gotta start out with my white papers. I gotta define what it is I'm actually doing, and just then I can go from there into actual coding. You know, but for me, it's just not like I do it like I write my code like I write my term papers. Get the big ideas down, and then kind of just go.
And then the other
It's
thing,
really, it's really once you understand it,
Yeah.
and if the better you understand it, the easier it is to,
Oh, yeah.
to implement it. And when you put in that, this magic is going to work, and you want to continue on to the next coding problem without testing it,
No.
oh
Don't do
man, your
that.
life is so hard.
yep. And there are times when I would actually rewrite something because the first version didn't work. I can manage to fix it to make it work, and then it becomes so hokey or kludgy.
But now you understand.
But now I understand, and then there's this unexplainable urge to just delete whatever I have and start from a blank slate. I don't even copy or look at
I
the
don't
old
copy
code.
either.
Yeah, I don't even look at the old code. Just delete it and just start from scratch.
That's how I got over Android Studio. I started these projects over and over again. Good, I got it working. All right, done. New project. Okay, click, click, click. Okay, what did I have to put in here? Oh yeah, I got it. And don't just pick it up and copy it and say, okay, good, I've copied the next
Retype it.
version. Yeah, you really type it, and
Yep.
and that's
Which is so much
and
easier
that's
when
what
you have two
connects the head.
monitors.
Yep.
Hmm?
It's just so much easier when you have two monitors too.
Or
Then you
4K.
have-
I kind of just like look at the
Or
old
two
code just to
4Ks.
remember how to write something, just so I can just like look at it again. Okay.
That's
I
fair
just know
too.
how to
Just
write
don't
it.
copy and paste.
Yeah, just don't.
I mean,
yeah.
you'll be surprised what finger memory
Yeah, I
will do to
try
you.
Yep.
sometimes to just do it from memory. Occasionally, if there's like a certain keyword that I'm just not remembering, I'll go look at my code.
Oh no, it's not a problem to
But-
cheat. It's just when you start off every time,
I like
you
to
pick up where you
try.
were and you copy, you paste, and you start off from that. And then one day someone says, "Can you get started?" You're like, I don't even remember how to start it.
Yep. The worst thing to start is to use an existing program as a basis and then try to modify an old program to do new things. I cannot do that. Some people are very good at it.
No, it's I love the refactoring tools because
Yeah.
when
Oh,
I'm
yeah,
done,
Android
I'm not
Studio?
done. I'm not done until I can't figure out how I can squeeze out the last line of code. And I'll refactor things, and I'll remap things, and I'll rewrite things, and as long as
Android
I'm getting shorter
Studios,
and shorter and shorter, I'm happy.
Mm-hmm.
The one
I
in
don't-
Android Studio is pretty damn good.
And most of the time, like on a project, I'll actually add features, and we'll have less code. Because you should always clean up as you go.
Because
But
you're
test it.
Because you're condensing.
Yeah, test it. I mean, a
Yeah.
lot of stuff is you think you needed to go from over there to get over to here, and then you see I can go from here to there.
Yeah, usually when I make a game, I have like one test program that I basically like dump a bunch of stuff into, and then like I just like kind of test out how things will work, and then I just jump to a new one, and then I just start fresh, just start from there.
You gain more skills the
Yeah.
more you. I mean, if every time you start, I mean, other people can't do this. You can't be a carpenter or something like that and take your old chair to start your new chair.
But these days, yes, we can because we
Yes.
got 3D scanners and 3D
Oh,
printers.
yes, you can. Well, no, once
And yes,
you scan
you
it,
can-
now you
you
have
can
an
ev-
STL file.
You
and
can
now
even
just
have
run through the
spools,
printer.
where they integrate wood particles into the polymer,
Yeah,
so
I've
it's
seen those.
wood-like. Even smells like wood.
And it tastes good too.
It tastes like wood.
I want the Hershey's chocolate printer.
It'd be cool if you could just like take like a 3D object, just put it in a printer, scan it, and then put it in your computer and change it. Then
Yeah,
then
That's what's
start
happening.
printing
Yeah,
They do it
That's
now.
been the goal. Yeah.
That's what we have.
So they start out. They
They
did
have
these.
the
They
scanners.
there's a photographic roundabout thing like they did the little
Now they have
models
the
or something.
handhelds. That's what Charles Kinter over in Art New Media has. He has the handheld one. He can scan people. He can then go into Maya and Retopo, and then send it to his printer. I think he charges like $50 to do it.
I mean, we have to do this if we're going to Mars. Because
Can
we
we
can't
send
bring the
Trump to
tools.
Mars first?
We have to print whatever we need while we're there.
Yeah, we can just put like for material, we can just like take some rock or something and just like put it in there.
Well, what's really going to be cool though is, and you'll see it happen in software, where the software was written in the software. Like, I mean, I can imagine a C++ compiler is written in C++. I mean, how did you do that?